Okay, and this next problem is definitely not in the correct order. Probably the easiest thing to do is to go ahead and subtract the y and bring the y over, so we get negative y equals x squared minus 2x minus 3. But we don't want a negative y, so we'll divide everything by a negative 1, which gives me a negative x squared, a positive 2x, and a positive 3. Okay, from there I can go ahead and figure out my vertex. My vertex is negative b all over 2a. So I end up getting negative b all over 2 times negative 1. So my x is equal to negative 2 over negative 2, which is a 1. So I have x equals 1 here. My vertex is 1 comma something. I can figure out my actual vertex by plugging in 1. So when I plug in 1, I end up getting negative 1 plus 2 plus 3, which happens to be 4. I know that this is going to open down because the a is negative. That means if it opens down, that it has a maximum. The maximum value then would be 4, 1, 4. The domain is always all reals. The range, since it's opening or is going down, means that y is less than or equal to 4. The helper point is 0 comma something. So when you plug in 0 here, actually I want to plug it in right here on this one because it already has y by itself. I get y is equal to 0 plus 0 plus 3, so the helper point is 0, 3. Graphing 0, 3 puts me right here. The other point then would be exactly the same distance away across from it. So 2, 3 is my other helper point. And then it goes down. Next problem is already in the correct form, so we'll just go ahead and find what its axis of symmetry is. So I've got negative b, which would be 0 all over 2 times negative 1. So my axis of symmetry is 0. This is going to be one of those special cases then again because I won't be able to find my helper point using 0. So I'll put 0 in, and I get 0 plus 2. So that means my y value is 2. 0, 2 is right here. Since a is negative, I know it goes down. If it goes down, that means it has a maximum, so the maximum value is 2. The domain of this function is all reals because it's a parabola. The range, the highest value because it goes down, is 2. So y has to be less than or equal to 2. The helper point I can't use 0, so I'm going to use 1. 1 comma something. So if I come up here and I plug in 1, y equals negative 1 squared plus 2. I get negative 1 plus 2 because 1 times 1 is 1. So y is 1. 1, 1 would be my helper point. Directly folding this in half would put me over here at negative 1 for my other helper point. And then I'll sketch my picture. This next problem will go directly into finding the axis of symmetry, negative b all over 2a. So I get negative b, which would be negative negative 8, all over 2 times a, which is 4. So I end up with 8 over 8. So my axis of symmetry is 1. My vertex is 1 comma something. So I end up getting 4 times 1 squared minus 8 times 1. So 4 minus 8 is negative 4. I know that this is, because the a is positive, it's going to open up. If it opens up, that means it has a minimum. The minimum value happens to be negative 4. The domain is all reals. 1, negative 4. If it opens up, okay, all the values are above negative 4, so the range has to be that y is greater than or equal to negative 4. The helper point is found by plugging in 0, so when I plug in 0, I get 0 minus 0, so y is 0. Plug in 0 for x, got 0 for y. Here's where I'm folding it in half, so a distance of 1 away, go a distance of 1 away. The other helper point is 2, 0. And then sketch the parabola.